Hello, my name is Hao Lo, and today I'm going to demonstrate how to derive continuity equation in cylindrical coordinates. The first thing we have to know is continuity equation is from mass conservation. So delta M is equal to mass flow into the control volume minus mass flow out of the control volume. Next, the mass inside control volume will become rho multiplied by delta R, delta Z, and R delta theta. It will look like this. The mass flow rate in R direction will be rho multiplied by VR, velocity in R direction, and area, the cross section of velocity in R direction, where is R delta theta multiplied delta Z. Before talking about the mass flow rate out of the control volume, I want to discuss some concept in linear functions. In linear function, if we want to find y2 based on y1, we can use y2 equals to y1 plus partial y partial x multiply delta x here. And using the same concept, we can find the mass flow rate flow out of the control volume based on the mass flow rate in control volume, which is the same value here, and plus the partial R of all the terms in mass flow rate in, and multiply delta R over here. Doing the same process in theta direction, we can have rho multiplied by velocity v theta in theta direction here, and the area through the theta direction, which is this delta R multiplied by delta Z, is this one, which is the mass flow rate inside the control volume in theta direction, and minus the mass flow rate out of the theta direction from the control volume, which is this one. Same process, Z direction would look like this. Next, we take everything constant out of the equation, the partial derivation. So for partial t, delta R, delta theta, delta Z, they are all constant. And for R direction, rho, VR, R, they are the only thing dependent to R. So we take delta theta, delta Z, and delta R out of the equation, which would look like this. And in theta direction, rho, v theta, they are all dependent to theta, the angle, which is theta, and we take delta R, delta Z, delta theta out of the equation. In Z direction, having the same process, we can take R, delta theta, delta Z out of the equation. Let's divide all the equation by R, delta theta, and delta Z. Then we can get partial rho partial t equal to minus 1 over R, partial rho VR R, partial R, minus 1 over R, partial rho v theta, partial theta, minus partial rho vz, partial z. And bring every term to the left hand side. We can get a partial rho partial t and look like this. This one is the continuity equation in cylindrical coordinate, which is what we want to do in this video. If rho is a constant, which will look like this, the continuity equation will become like this. We can simplify everything about rho and write it as 1 over R partial VRR partial R plus 1 over R partial v theta partial theta plus partial vz partial z. The whole equation will become 0.